What if you could talk to a friend in a secret language that only you two understand? You could send each other messages that nobody else can decipher. You might be surprised to learn that AI can do something similar. It can take in a sentence, break it down into tiny pieces, and then translate it into a completely different language. But how does it do that? Let's find out. Imagine you're at a restaurant and you want to order food. But the waiter only speaks a different language. So, you use a translator to help you communicate. The translator breaks down your sentence into tiny pieces, like individual words, and then translates each word into the waiter's language. This is similar to how an encoder-decoder architecture works in AI. The encoder is like the translator, breaking down the sentence into tiny pieces, and the decoder is like the waiter, putting the translated pieces back together again. Let's break down the encoder-decoder architecture into its individual parts. The encoder takes in a sentence, like hello, how are you, and breaks it down into individual words, like hello, how, are, and you. Then, it looks at each word and says, oh, this word is associated with this meaning. The decoder then takes these associated meanings and puts them back together again to form a translated sentence, like bonjour, comment vas-tu? But how does it know which words to associate with which meanings? That's where the magic of neural networks comes in. Let's take a look at an example. Suppose we want to translate the sentence I love playing soccer into French. The encoder breaks down the sentence into individual words, like I love playing and soccer. Then, it associates each word with its corresponding French word, like j'aime, jouer, and football. The decoder then puts these translated words back together again to form the sentence j'aime jouer au football. And that's how you can use an encoder-decoder architecture to translate sentences from one language to another. So, why is this important? Well, it allows us to communicate with people who speak different languages. It also enables us to build machines that can understand and respond to human language, like chatbots and virtual assistants. And it has the potential to revolutionize the way we interact with technology, making it more accessible and user-friendly for people all around the world. So, let's recap what we've learned. We've learned that an encoder-decoder architecture is a type of neural network that can translate sentences from one language to another. We've seen how it breaks down sentences into individual words, associates each word with its corresponding translation, and then puts the translated words back together again. And we've explored some of the reasons why this technology is important, from enabling communication across languages to building more advanced machines that can understand human language. Next time, we'll explore how these neural networks can actually learn to translate languages on their own, without being programmed with every possible translation. It's a powerful technology that has the potential to revolutionize the way we communicate with each other and with machines. So, be sure to subscribe to our channel and hit the notification bell to stay updated on new videos. Thanks for watching, and we'll see you in the next video.